Hi, folks. Professor Gulliford. We're moving ahead to chapter 4 now. Let's go ahead and do a share screen, share sound, optimize the video, and we'll find our PowerPoint for chapter 4. And I've already added case 4 to it, so we should be all good to go here. It's the pulmonary, bronchial, and systemic circulation and the blood. Wow, that's a lot to cover in one chapter, but here we are, and we can do it. What we talk about all those things, the structures of the pulmonary, bronchial, and systemic circulation, flow of blood through the circulations, um, common disorders of pulmonary circulation, components of blood, physiologic processes that affect the blood groups and RH groups, and then pulmonary hypertension and the various types of it. Pulmonary hypertension is a big deal in respiratory therapy, and what we need are selective pulmonary vasodilators to open up the blood vessels in the lungs and bring the blood pressure down. That's something that we're really working hard for, and we have gotten better at it. Pulmonary circulation begins in the right ventricle. This is how the blood gets to the lungs for picking up oxygen. And then the bronchial circulation supplies blood to the tissue itself in the lung. The lung needs its own blood supply. It's no different than any other organ. It's just that it's doing a very important thing, which is respiration, bringing in oxygen and bringing out carbon dioxide. Systemic circulation carries the blood through the body, collects the deoxygenated blood, and then returns it to the right atria. And the process begins again. I remember this very graphic here. When I was a student, and I thought, wow, that's a lot on one picture. And it is, but that shows you the whole route that blood has to go through in order to keep us alive. You have to get blood from the right heart to the lungs, drop off the CO2, pick up the oxygen, bring it back to the left heart, which pumps it out to the body, all parts of the body, all the organs, internal organs, all the tissues. And then when it goes through the tissues, a lot of the oxygen is extracted. And what we get is deoxygenated blood, that's shown as blue, headed back to the heart to start the whole process. Again, they show in green here the lymphatics, which have to be involved in order for this all to work effectively. It's remarkable, that nature figured all this out, and we don't even have to think about it. Arteries are the blood vessels that carry oxygenated blood away from the heart. I put those in red because red is the color of oxygenated blood, and arteries and away. My professor said that years ago. A for artery, A for away from the heart. The pulmonary circulation, this is reversed because the arteries are taking deoxygenated blood from the heart to the lungs, and then the veins are bringing it back to be pumped to the rest of the body. So a little trivia question for you, use this on another colleague or maybe one of your nursing students or something. What's the only artery that carries deoxygenated blood? It's the pulmonary artery. Okay. Only the pulmonary artery carries deoxygenated blood. That's the map of all the arteries and veins. It would take the rest of my class period to just go through all of that. But let's suffice it to say that you're going to know every artery and most of the veins. We don't deal quite as much in veins in respiratory therapy, but we use a lot of them. Definitely the radial, definitely the brachial, definitely the femoral. There's one on the top of the foot that I've used several times to draw blood gas. It's called the dorsalis pedis, and that is an artery that's very superficial. We only go there as kind of a last resort, but sometimes we go there. Normal cardiopulmonary values. What we're going to talk about is the pressures in various parts of the cardiopulmonary system. One easy way to get those these days and to look at the actual function of the heart is an echocardiogram. Echocardiogram is a amazing technology that has advanced so much in the years that I've been involved. You can also do a right heart catheterization. That's a pretty invasive way to do it, but nonetheless, we sometimes do that, particularly in the critical care unit. It's called a pulmonary artery catheter. At the hospital, you're going to hear people say Swan Gans, but Swan and Gans are the names of the two doctors that invented it, and you will not see that on the board exam because they're not going to use a brand name ever on the board exam. So, echocardiogram, we're not going to make echo techs out of you, but some RTs do cross-train to do this. Basically, it uses sound waves to make amazing pictures of the heart as it's beating. It also shows you the flow of blood. It's called color flow ultrasound. And you can actually see if there is a leak, if there is a reversal of flow, if there is turbulence of flow. All that stuff shows up beautifully today on an echocardiogram. Three types of echocardiogram are 2D, M mode, and Doppler. And I think that's really all you need to know, except that the pictures are amazing these days, just amazing. Right heart catheterization is a procedure that measures all the pressures in the heart using a pulmonary artery catheter. That's what's going to be called a Swan-Ganz catheter at the hospital, but on your test, it's a pulmonary artery catheter. Right heart catheterization allows us to measure pressures that can be used both for diagnostic and for treatment purposes. You will need to know the pressures at the various different parts of the system, the heart and the lungs, and we will make sure that you know those. It's called hemodynamics. Hemodynamics. Let me just add that, because that's a term that you will definitely hear. Okay. Now, right heart catheterization gives us the actual cardiac output, how much blood is being pumped per minute. And it's about 4 to 8 liters per minute. That's how much blood is being pumped out of the heart per minute. Here is something that was definitely on my own test when I took it. I took the test just to see what it was like, to see if I could maybe help you folks better. And this was for sure on my test. Cardiac index is cardiac output divided by body surface area. So the units are liters per minute per square meter. Liters per minute per square meter. And they turn out to be about half of cardiac output. So roughly 2.8 to 4.2. The pressures in the system, you'll learn much more about this in critical care class, but right atrial pressure, which is CVP, about 0 to 7. Pulmonary artery systolic pressure, about 17 to 32. A lot of them seem to be right in the 20s. Mean pressure, pulmonary artery mean pressure, about 9 to 19. Pulmonary artery diastolic, about 4 to 13. And the wedge pressure is one that definitely shows up on boards. Pulmonary capillary wedge pressure is 4 to 12. If the left heart is failing badly, that can go up as high as 25 or even higher. So left is wedge. If the left heart fails, the wedge pressure goes up. Deep venous thrombosis is a big problem. Clots form in the patient's leg, and then they move quickly to the lung. That's called a pulmonary embolism. So deep venous thrombosis, pulmonary embolism. PE is a life-threatening situation. It's one of the 2 times that the NBRC uses the word sudden. I'm actually going to add that here, sudden. The other time is pneumothorax. So collapsed lung or pulmonary embolism, both of those are sudden. And what we actually wind up with is death of tissue for lack of blood supply. That could be true in the brain, that's stroke. That could be true in the heart, that's a myocardial infarction or heart attack. That could be true in the lung, and then that is infarction, pulmonary infarction due to pulmonary embolism. And there we go. That's showing a picture of the clot moving from the leg up into the heart, where it is pumped into the lung and then causes a immediate life-threatening situation, if we don't take quick action here. Oh yeah, common board question, what medicine first? Now, obviously, the first thing you're going to do is oxygen. Definitely the first thing to do is oxygen, but the very next thing is heparin. Heparin is the very next thing to do. Pulmonary hypertension is a group of progressive diseases. characterized by pulmonary vascular resistance. There are various types of it, 5 groups, and we are going to quickly cover those 5 groups for you. I don't see a lot of board questions about that. I will just be honest with you, but we are going to cover the 5 groups. First one is pre-capillary pulmonary arterial hypertension. All right. And this could be idiopathic, it could be inherited, genetic, it could be drug or toxin induced, like amphetamines. Meth, can cause this. PAH associated with systemic diseases. So that group 1 is pre-capillary pulmonary hypertension. And then there are some subgroups of that. Long-term responders to calcium channel blockers and veno-occlusive diseases. This is getting to a level that you really don't need as a respiratory therapist, to be honest with you. We don't see this on boards, but nonetheless, we'll just go over it and you'll have that background knowledge. Pulmonary arterial hypertension, persistent pulmonary hypertension of the newborn, PPHN. When you do the pediatrics class, you're going to see there's a lot to learn that is unique of kids, and PPHN is one of those things. It occurs when the fetal circulation fails to transition to normal at or after birth. Normally, at the first breath, there's a ductus arteriosus and a foramen ovale, I had to think for a minute, that close. Those are openings that are in place while the infant is developing in mom, but they should close at the time of birth. If they don't, we've got a problem, and we've got to get those to close. And we can do that. We know how to do that these days. So, all right, group 2, left heart disease. If the left heart is bad, you will get pulmonary hypertension just because of blood backing up through the system. And this is due to a reduced ejection fraction. Pretty much anything less than 50% ejection fraction. I mean, 50% of the blood gets pumped out each time the heart contracts. Anything less than that, we start to have trouble. And this would be one example of that. Could be a valve problem, could be a congenital problem. There are just a lot of different causes, but the basic problem is that the basic problem. I've skipped a slide, and I'm sorry, I'm going back here. The basic problem is that the left heart is failing. There's the slide that I wanted to get. Group 3. Group 3 pulmonary hypertension is due to lung disease, maybe emphysema, maybe pulmonary fibrosis, chronic hypoxia, and pulmonary hypertension develops because of those bad lungs. So type 3 is due specifically to lung disease. It could be due to smoking. It could be due to chronic exposure to some bad substance, dust, for example. Could be a developmental problem that the person's had all their life, lots of different ways. Group 4 is thromboembolic. There's a clot that's actually causing the problem. And what we got to do is dissolve that clot and get rid of it. Heparin, streptokinase, TPA, tissue plasminogen activator, and we know how to get rid of the clot. Can we get rid of it quickly enough? That's the real question. Type 5 is unclear, so there are multiple factors involved that we just really don't know. This group includes things associated with disease state, why it happens, not clearly understood. You might say this is idiopathic. One of my professors said when a disease is idiopathic, that means that we're idiots about it because we just don't really know. We just don't really know why it is happening. So there you go. You got your 5 types of pulmonary hypertension. You might see a question on that in this test. I've not seen a single board question about it, though. Diagnosis of pulmonary hypertension, elevated mean arterial blood pressure. This for sure is on boards. If the mean pulmonary artery pressure, this was on one of my students' tests last week. That's how current this information is. The mean pulmonary artery pressure is greater than 25. That's pulmonary hypertension. That is your definition of pulmonary hypertension. I think that's worthy of putting in red or something to make it really stand out for you. Mean arterial pressure Mean pulmonary artery pressure greater than 25 is the definition of pulmonary hypertension. Let's see here. Pulmonary hypertension, still talking about the different groups. You just honestly, we're at a level now that you don't need that kind of detail. So I'm going to move along here. Moving to blood. Blood, so important. I might mention that I personally had a iron deficiency anemia. I had no idea, but I just didn't have a lot of energy. Kind of felt weak. I thought, well, maybe I'm getting a little older. Maybe that's how you feel when you get a little older. No, went to have some labs done, and my hemoglobin was very low. My iron level was very low, and my B6 and B12. So they gave me the list of iron-containing foods, and I said, Terry, wife Terry, this is a list of things I never eat. That was exactly right. So we've made some dietary changes, but most importantly, we're taking iron, B6 and B12 every day. Yeah. The volume of, and my hemoglobin's now 13, where it ought to be. So volume of blood in the body, about 7% of total body weight. Yep. About 1.2 to 1.5 gallons, or that would be 4 to 5 liters roughly. Yep. It does vary somewhat by gender, but something in that range is going to be, correct. Maybe 3.8 to 4.9 liters for women. Women do have a little lower hemoglobin and red blood count for exactly the reasons you imagine. The monthly menstrual cycle takes a certain amount of toll on that. Yeah. Bone marrow is where the blood is made. And, when I had my iron deficiency anemia, the hematologist explained to me that my bone marrow was perfectly healthy. It just didn't have anything to work with. It didn't have any iron or any B vitamins to make blood from. So now it does. And, I'm so much better. Red bone marrow consists of hematopoietic stem cells. Hematobo is blood. Poiesis is to create. So cells that create blood give rise to erythrocytes, platelets, and most of the white cells as well. It's called hematopoiesis making blood. That's about all you need to know about that, I think. Yellow bone marrow is found in the central cavities of long bones, and this contains mesenchymal stem cells, merostomal cells, and they produce things like fat, cartilage, and bone. Yeah. So red bone marrow and yellow bone marrow, both very important for human health. The blood that flows through the pulmonary and systemic circulations is composed of red cells, white cells, and platelets. Think of the platelets as like little plugs that stop a leak when there is bleeding going on. The blood cells are in a liquid called plasma, and that plasma is about 55% of blood volume. It's straw colored and contains water, salts, enzymes, antibodies, other proteins. Most importantly, it contains the blood cells that actually, do what need to be done in our body. Carry oxygen for sure, fight infection for sure. It's the miracle, of nature. Just wow. Now we'll talk about each type of cell. Let's see how we're doing on time here. About halfway. You know what? I may not be able to finish this tonight, but that's okay. Let's talk about at least the type of cells, and then we'll do the second half tomorrow. But erythrocytes, the red cells, they mostly transport oxygen and carbon dioxide. That's the big thing they do. And you've got to have hemoglobin to do that. Average lifespan of an erythrocyte is 120 days. So they live a pretty good amount of time, but then eventually they have to be replaced. If they're not replaced, then what happens is the patient's red blood cell count goes down, their hemoglobin goes down, and they have anemia. And that's one word that you definitely need to know, is that anemia is a low hemoglobin level, a low red blood cell count. And we see an awful lot of that in medicine. Low blood count. Hey, Terry. Low blood count. We're going to do 2 more slides tonight. Well, maybe 3 more, and then we'll call it good. Hemoglobin is what I was so low on for lack of iron, B6, and B12. So you will be a patient too. Understand that while you're taking care of other patients, you're also a patient yourself, and you probably won't be a very good one. Medical people are not terribly good about that. But hemoglobin, abbreviated at the hospital, it's just HGB usually. But it allows the erythrocytes to carry oxygen. Hemoglobin is made up of 4 protein molecules, globin chains rather, and a hemi group. That's what makes it hemoglobin. There are several different kinds of hemoglobin in everyone, including fetal hemoglobin. We also have a little bit of methemoglobin. We have a little bit of carboxyhemoglobin because as long as you're somewhere around motor vehicles, there is a little bit of carbon monoxide. If you smoke, your carbon monoxide level is significantly higher. I just mentioned those levels. This has been a test question on the boards. Hemoglobin or a carboxyhemoglobin above 20 is considered lethal. Most of us, if you don't smoke, but you live in a metropolitan area of any kind, would have a hemoglobin or a carboxyhemoglobin of 3, 2, 3, 4, something like that. Smokers more like 7, but 20 would be lethal. Yeah. So if you ever wondered, how does the doctor know the patient is still smoking? It's their carboxyhemoglobin level. They can't lie about that. We measure that and we know they're still smoking. So it's just the way it is. Measuring erythrocytes, we can actually measure the size of the erythrocytes. B12 deficiency, look here, there. Yeah, that's very much what I had right there. Folic acid deficiency, those kind of things. All that can lead to anemia of various kinds. Mean corpuscular volume, mean corpuscular hemoglobin concentration. All these things are measured and part of the blood count. Hematocrit measures the number of red blood cells compared to the total blood volume. So you might think of it as how concentrated the blood is with red blood cells. Normal for men about 40 to 54, women 36 to 48 for the same reasons we mentioned. And both these things are based on the whole blood volume and are dependent on plasma levels. So let's see here. I think that's all you need on that slide. The next thing we'll talk about is blood types, and we're over halfway through this presentation, so I'm going to call it good for there, and I'll get this uploaded tomorrow. I will finish this chapter and probably also get chapter 5 done. I want you to have it for the long weekend in case you want to, get that accomplished. And also I'll give you case study 4. So really enjoy working with you folks. Excellent work. I just graded everything in the grade book, and you folks are well on the way in this course. Well on the way. The work is excellent. Just keep it up. See you in class.